Welcome to Research Design Week 1. I'm excited to start this class and to start this lecture. What we're going to go over today is just kind of an introduction to research methods. There'll be some basic topics that we cover, but there'll be some more complex topics as we get closer to the end of this presentation. So, purpose of this course, there's two main purposes. One is how to do research, and we'll go over the steps of how to do it. I think more importantly, though, is how to read research. So the main portion of what we're going to do is we're going to do a lot of article critiques, article reviews, and we're going to become a critical consumer of information. So we're constantly hearing about different research studies as we read through the media. I want you to be comfortable going to the original source and reading that research and kind of deciding for yourself what to get out of that research. So as we talk about this class and what I'm expecting, we're going to do a lot of science. We're going to think like scientists. So there's a sort of figuring things out idea in science, and I want you to question things and have a lot of curiosity as we go through these topics. So also, I want you to be skeptical. So if there's anything that I ever say or you disagree with, I want you to be skeptical of what I say. So like we are as therapists, we're going to be questioning things, we're going to try to figure things out, and we're going to recognize the interesting phenomenon. So I think science and research is very much like what we do in therapy. It's a very similar process. We're trying to figure out what's going on in this methodological type of mystery, and also in what's going on with our patients or clients. So we think of science as being very cut and dry, but there's very much a lot of curiosity that we have to play into this, and a lot of artistic type of nature. We have to think outside of our usual ways of thinking to try to get at these different phenomena. So I don't want you to think science is very much mathematics. We're not going to go much into math in this class, or statistics, so into a little bit, but we're not going to get into the math part of it. We're going to think about how do we figure out this question that we have. So one of the more important things that we're going to cover are some ideas, and one is experimental versus correlational studies. And I'll go into more detail about this, but correlational studies are thought to be this idea of we're looking at real world phenomenon and we're seeing what's happening. Experimental are controlled, where we're controlling all of the variables. We randomize people into groups, and we then see, does our intervention have an effect? And it's always been thought that experimental are better because we control more things. But there are some advantages and disadvantages to each. In correlational studies, we can see how things are happening in the real world, and that may not be applicable in an experimental study. So we'll kind of go through this in more detail as we go through this class. But again, correlational research, we're looking at the relationship between variables. A correlation is a relationship between variables. And we do it in situations where we sometimes can't do experimental research. If we want to find out if school is useful for kids, we can't just assign kids to not a non-school condition. We have to, see what's happening in the real world. So there's a lot of situations where we can't do a controlled study. There's a study with parachutes, or kind of a joking type of study, like, there's no evidence for parachute use because there's no controlled experiments using parachutes and versus not using parachutes. That idea that we have to do an experimental study to show something works, we can't always do that. And then also with correlational research, it generalizes maybe better to the real world. When you're coming into a laboratory, if you're doing a drug study, you're going into a situation, you might be acting in a different way because of this drug study, where in the real world, when you take your medicine in the morning, and how you take it with food is maybe more generalizable to how people will take that. One of the most important things that you'll learn in research design classes, and I put 2 stars next to it, meaning it also might be useful for the quiz, is that correlation does not equal causation. So there are situations where variables can be associated with each other, but they don't equal causation. So So we might have a third variable, we might have some other reason why these variables are associated. So I've got all these examples. So this is the number of drownings, swimming pool drownings per year. So we've got the years along the bottom, and then the number of films that Nicolas Cage starred in that year. So this is maybe getting a little dated, but you can see that clearly there's a relationship between Nicolas Cage films, the number of films, and the number of drownings per year. And it almost maps out perfectly. So we might say that Nicolas Cage films cause more drownings, but that's probably not the situation. It's probably just a spurious correlation where these two things are not related at all. Divorce rate in Maine and the consumption of margarine. So we've got how the divorce rate and how much margarine is consumed. So as margarine consumption goes down, divorce rate goes down. Autism rates and organic food sales. So if you look at this correlation, you might think that organic food sales are related to autism. It's just, again, another spurious type of correlation that these two things were becoming bigger events over time. All right, so this is a study that came out in July of 2007, Preventative Medicine, and I like to look at this study to think about correlation and causation. So it's this idea that candy cigarettes, so kids who play with candy cigarettes might be more likely to smoke cigarettes as they get older. And what they did a sample of 26,000 of adults, and they looked at whether they played with candy cigarettes when they were younger, and they found that people who played with candy cigarettes as kids were more likely to smoke as adults. So we have this correlation between these two variables. If you play with candy cigarettes, you're more likely to smoke as adults. But is this really the cause of later smoking? So we're going to look at this study in more detail as we go through some of these other slides. So these are what we think of as the prerequisites for inferring causality, for saying something causes something else. So the first prerequisite, and again, when I have 2 stars, it's probably a pretty important concept. Maybe you might want to remember this for the quiz. The first is that correlation. There's a relationship between the two variables. So when we're thinking about causality, we need that correlation between the two variables. Otherwise, we wouldn't say it's a causal mechanism. The second, which is a little bit more difficult to get to, is that your cause must come before the effect. So in the candy cigarette example, we have smoking candy cigarettes comes before smoking as an adult. So we have number 1, we have a relationship, and number 2, that one comes before the other. And then the third, which is the most difficult to get, most difficult prerequisite to get, is that you have to rule out all alternative explanations. So you have to rule out that maybe they played with candy cigarettes because their parents smoked, and their parents smoking might be the reason that they smoked, might be other causal factors, maybe for some kids, it's not the candy cigarette use, it's that they had to buy the candy cigarettes the same time as, parents were buying other cigarettes, or whatever other variable it is. And this is the most difficult one to rule out. There are many other explanations that could play a role in this, and it might not be that candy cigarettes cause adult smoking. So this third alternative is one of the reasons that correlational studies are thought to be lesser than experimental studies. But again, you can't take kids and have them play with candy cigarettes and then control everything else in their life and see as adults do they smoke. We can't do an experimental study with that. We can only look at correlational reasons for that. So experimental research, on the other hand, is when we have a lot of control over our experimental conditions. Usually we're comparing 2 conditions, an intervention versus a control group, or there could be more interventions we're comparing, but we're randomly assigning people to one of those conditions. So that random assignment, we'll get into more detail of random assignment means. It's just taking people and they randomly can go into one group or another group. And we think that that random assignment controls for any sort of experimental bias. And so by putting them randomly into groups, we control for that bias. We don't want people picking their group because that could bias the results, or the experimenter picking people to be in one group or another because that could bias things. So we randomly assign people to groups. And then we control all the experimental conditions. And the only thing that we adjust is our intervention. And we call that the independent variable. And we'll go over independent variable in more detail later, but we control the independent variable. That's what we manipulate. So we think that everything else is exactly the same. The only change is that condition of the independent variable. One of these other concepts that I'm interested in, one of the reasons that I really got into statistics and research methods is nomothetic versus idiographic type of studies. And when we're doing statistics, and a lot of the articles we cover in this class will talk about nomothetic studies and this sort of average over everybody. And then I really was interested in idiographic and what makes the individual different. What are those individual differences that lead to change in therapy is really what I was interested in. So let me show you in a slide. This is some data that Jackie Persons, she's a therapist in San Francisco, collected. She measures everybody that comes into her large clinic, and it measures people over the different sessions. So along this x-axis, we have the number of sessions. And then on the y-axis, we have positive affect. And positive affect, it's a nice variable because it goes up over time. We think it'd go up, people become happier. It's not the exact opposite of negative affect. So negative affect would be depression and anxiety. Positive affect would be more happiness. So they're not necessarily exactly the opposite of each other, but you can kind of think of them on a dichotomous spectrum. So what we see is across time, if I draw this red, I'm not drawing a very good red line, but what we see is that people go up in their positive affect across therapy, which is a good thing. So if we did a study on this, I would say on average, in this type of therapy, people are getting happier or getting better. And so this is a pretty interesting finding. We could say that therapy works, and this is what often happens in research. We look at the average trajectory or average number, and we say that it works or it doesn't work. But if we look at the data a little bit more carefully, and each one of these lines represents a person, we see differences in how people reacted to therapy. So for example, this person here started off kind of in the middle of positive affect and just became the happiest person in all of the people who went through this therapy. And very quickly, within 5 sessions, this person just skyrocketed in happiness. We also have a cluster of people that really did well in therapy, and they did better than the average. So what about these people make them different than the average? And is there something that happened in therapy? Is it something within themselves that made them different, that made them strong responders to this type of therapy? And then on the other hand, we also have, let me just clean up the slide a little bit, also have people who didn't do as well. So this person here actually came into therapy, one of the happiest people to come into therapy, and across all the therapy sessions became one of the least happy people. And we have another, couple people down here that also didn't do well in therapy and actually became less happy over the course of therapy. So what is it about these people that are different than the average? The average, everybody's getting a little happier on average, but for these individuals, they're not becoming happier, they're becoming less happy. So was it something personality-wise? Was it something with the relationship with the therapist? Was it something that happened in the therapy that made them less happy? It would be interesting to know, and that we could maybe improve therapy for these people, or make some sort of change. Maybe it takes 52 sessions, and over time this person comes back up. Those type of things are questions we could then ask that are more idiographic. Where we're looking at the individual differences and what about this cluster of people is different. All right, so when we're talking about science, we're not talking about intuition that just feels right. We're not taking what authority figures tell us or taking anecdotal evidence. We're actually using rationalism and empiricism, where if this happens, then that, and then we're going to test the idea, and we're going to test it over and over again. So this is the if then that, and then we test it, empiricism. These aren't too important of terms, but just to kind of think about science. When we do research, we're not looking through the internet and finding out what some reviewer said on Amazon. We're actually collecting a bunch of people, or we're collecting a bunch of time points to find out if something exists over and over again over time. So that's the definition of science we're going to use. One of the concepts we're going to talk about is accuracy versus reliability. And again, we have these double stars, so it could be important for your quiz. Accuracy is what we're measuring what we want to get at. So are we getting at the exact measurement? So if we're trying to measure depression, is the measurement of depression correct? Reliability is, do we get the same measurement every time? So there's an example in the textbook about a dartboard. I could hit the same spot every time in the dartboard, but it probably would not be the center. So I'm reliable, but I'm not accurate. So I'm not hitting the center, I'm not accurate, but I'm always hitting the same wrong spot, so I'm reliable. We need reliability before we can have accuracy. So reliability, we have to be in the same spot all the time before we can have accuracy, because if we're hitting the middle once in a great while, it doesn't really mean anything, because we never know where we're going to be on the dartboard because we don't have reliability. So that reliability is the foundation, and then we want it to be accurate as well. All right, so just we're giving a lot of terminology today in this first lecture, just some basic terminology, but an observation versus construct. So observation is something we actually can measure and see. And many other sciences, we can measure things much easier. So we can measure mass and things like that in physics. But in psychology, there's very little we can actually measure. We can measure behaviors, we can measure physiology, we can measure something like heart rate. Those are things we can actually observe and measure. Constructs, on the other hand, are prevalent in psychology. These are ideas that explain our observations. So when we think of something like anxiety, we can't actually measure anxiety. We have things that we try to approximate anxiety. So we try to measure physiology. We'll try to measure heart rate, sweat response. We might ask the person about their anxiety, but none of these are actual observations of anxiety. We're measuring a construct of anxiety. And that's where we could get into trouble. So the better our measurement is, the better we can measure that construct. But because we're measuring a construct and it's not a real observation, we can get into some problems with measurement. All right, so we're going to talk about theory and hypothesis testing, and just kind of let me give you a broad overview. Next week's lecture we'll go into more detail, but a theory is this basic sentence or two that brings together all of the previous ideas. So it tells us kind of a overarching set of principles that organize what we've learned before. So our theory guides our research. So we might have a theory, David Clarke's theory of panic disorder is that thoughts can lead to a panic attack. So if you have misguided thoughts, we might lead to a later panic attack. So we have to test this out, and we test it out through our science, and we'll use things like hypothesis testing. So hypothesis testing is a way that we put up a hypothesis and we try to knock it down. And this is sometimes confusing, and I find it confusing the way we do this, is that we put up a null hypothesis. So a null hypothesis, and I'll put that in the next slide, but a null hypothesis is what we're trying to knock down. So we're always trying to knock down our hypothesis so we can come up with an answer to our question. So let me get into this null hypothesis. So I'll start on the bottom of this slide. So the null hypothesis is what we put up that we're trying to knock down, and it's always worded in this way that there's no effect, there's no relationship if we're talking about a correlational study, there's nothing happening. And so it's a null or nothing happening hypothesis. And if we can do our study and we knock down this, in our study we found something happening, so then we reject that null hypothesis. So our research hypothesis is our guess. This is what we think will happen. So research hypothesis is what we think will happen. The null hypothesis is saying nothing is happening, and that's what we're hoping to knock down. So again, here's a little bit more detail about the null hypothesis, is that there's no differences, no relationship. It's always worded as nothing is happening. And we put this up there again to knock it down. We can either reject or fail to reject. I have retained, but we can also say it as fail to reject the null hypothesis. So we do our study and we either reject it, so we say we reject that nothing is happening, and then we can kind of say that something's happening, or we fail to reject it, and then our study didn't find anything. So it seems like a backward way to do things is that we have to knock down this idea that nothing is happening in order to say something is happening, but that's the way that our statistics will work and other things will work with this null hypothesis testing. So we have to knock down nothing is happening. All right, so Sir Ronald Fisher, and I say sir, he was knighted. It's just kind of makes this quote seem even more important for some reason, but basically, every time we do an experiment, it gives us a chance of disproving the null hypothesis. So again, this sort of backward logic, we're trying to say that nothing is happening is untrue. So it's baffling a little bit, but it's the way we do testing. All right, this is going to be probably the most complex topic we have in this lecture. It's type 1 and type 2 errors. And I'm going to cross a little bit of things out of this slide that really aren't that important this week that we'll bring back in a later lecture. So we have different types of errors. So let's say we do this experiment and we test out our hypothesis that our treatment works, this new treatment we have. We think it's important. So with this null hypothesis, we set up a null hypothesis and we say treatment doesn't work. Let's see, sorry, it's hard to write with a mouse. So we can say the treatment doesn't work. And that's our null hypothesis. So again, the null hypothesis, nothing is happening. We do our experiment. We find out that that our treatment did work. So we find out some effect from our treatment. So we can reject that null hypothesis. So let's say, I'm just going to cross this bottom part out for a second. So we reject, this is our experimenter's decision. We rejected the null hypothesis. We found something in our study. We might have made a correct decision. So in the two columns, there really is an effect. If we knew what really was happening, there really is effect. Then when we rejected the null hypothesis, we'd say we found something. We made a correct decision. Or we made a type 1 error. And when we make a type 1 error, we've said something is happening that really isn't happening. It's a false positive. So another way to think about it is, let's say I take a pregnancy test. The null hypothesis for my pregnancy test would say not pregnant. I take it, it shows the little pink whatever it is, and it says that I'm pregnant. It could be a correct decision, but because I don't have the ability to become pregnant, I know it's a type 1 error. It's a false positive. So in that, we've rejected the null hypothesis that says I'm not pregnant, and it's a type 1 error. I'm not really pregnant. So I have a false positive. On the other hand, let me clean up this slide a little bit. So I'm going to change this top part, and let's look at, let's say we did our study, we did this long experiment, we tested the null hypothesis, we didn't find an effect. We can't reject. We failed to reject the null hypothesis. We might have made a correct decision if there's really no effect. Or we could have made a type 2 error where we failed to find something that really exists. We failed to find that effect. So we did our study, but we didn't find it. That's a false negative. So let me put it in terms that when we think about coronavirus testing, that might make more sense. If we do a coronavirus test, and let's say the null hypothesis is no coronavirus, let's say our test finds something and we really don't have coronavirus, that would be a type 1 error. We rejected the null hypothesis that we don't have it, and we say we do have it. That's a false positive. Let's say we did it the other way now. So we took the coronavirus test. It says we don't have it, but we actually do have it. That's a type 2 error. That's a false negative. The test didn't find something, but we really do have it. So that's the type 1 and type 2 error in a nutshell. I like to just think of a type 1 error as a false positive. We failed to find something, or we found something that really doesn't exist. And a type 2 error is a false negative. We failed to find something that really does exist.